Welcome to Foundations and Pre-Calculus Math 10 with Mr. Johns. We're on Chapter 4, we're looking at roots and powers, and today we're going to do Section 4.3, which is mixed and entire radicals. So, first thing we can do is find the square root of 4 times 9. And I would think of this as the square root of 36. Well, 36 is a perfect square, and we get the square root of 36 to equal 6. Now if I take the square root of 4 and the square root of 9, square root of 4 is equal to 2, the square root of 9 is equal to 3, and 2 times 3 equals 6. So the square root of 4 times 9 is equal to the square root of 4 times the square root of 9. And this is called the multiplication property of radicals. So the nth root of a times b is equal to the nth root of a times the nth root of b, where n is a natural number and a and b are real numbers. So now using this property, I can go, if we look at example 1, we can simplify the following entire radicals into mixed radicals. Now this can be a little bit tricky, but here's how it goes. The square root of 18. What I really want to do is look for perfect square factors. And I notice that 18 is equal to 9 times 2. Well, this is equal to the square root of 9 times the square root of 2, as per our multiplication property. So the square root of 9 is equal to 3, and then the square root of 2 will just leave. And this is called a mixed radical, because we have a whole, an integer value, and then a radical. This is called an entire radical because everything is under the radical sign. So for the cube root of 40, now I'm looking for cube root factors. Well, a cube root factor I'm seeing is 8. So 8 times 5, because 8 is equal to 2 cubed. And the cube root of 8 and the cube root of 5 is equal to 2 cube root 5. So here's our mixed radical. Now it's your turn. Try to make the square root of 75 into a mixed radical. Now radicals can only be simplified if they have a perfect square as a factor. For example, the square root of 14 cannot be simplified because writing it as square root 7 times 2 or 14 times 1 or anything like that, there's no way to take a square root of either of those numbers and end up with a nice number. So this cannot be simplified or turned into a mixed radical. Now the next thing we want to do is write the following mixed radicals as entire radicals. So there's a number in front and we want to put everything under the radical sign. So it's the reverse of what we were doing here. If I have 2 root 7, then what I need to think of is, what was 2 under the root sign? Well, it was the square root of 2 of something squared. So the square root of 2 squared is equal to the square root of 4 times the square root 7. And this is equal to square root 4 times 7 is equal to the square root of 28. Now some of you will not need to do this many steps, but I just wanted to be clear about how it works. For 3 times the cube root of 11, I'm going to think of it as the cube root of 3 cubed times 11. Well, 3 cubed is equal to 27 times 11. And this is equal to cube root of 297. Now it's your turn. Write 4 times the square root of 6 as an entire radical. Okay, your task is to complete the section 4.3 assignment 1, 2, 3, and 4. If you have any questions, ask. Good luck. See you tomorrow.